these questions, please make sure whenever you're adding or subtracting fractions, you're getting the same common denominator. So you look for those. Then you can just minus the numerator value. So we've got 7m on 8 minus m on 5. We've got to times this all by 5, this one all by 8 to get us there. Then you're going to have 35 minus 8m, and that will lead us to, well, take 5 away with 30, take another 3, will be 27m. So that will take us to 27m on 40. Then the last thing you should do is always think about, can I simplify that? Does 27 and 40 simplify? No, I can't think of a number it divides by. So that would be it there. Moving on to the next quiz. Most people got this one right, so I'm not going to worry too much about that, but that's a bit different. 3y minus y on 3. Let's do that one anyway. So just as a quick review, we've got 3y minus y on 3. This denominator is actually on 1. So I've got to get this to 3. So I'm going to have to multiply the numerator and the denominator by 3, which will make it 9y on 3 minus y on 3, because I've multiplied this by 3 and this by 3. 9y minus y leaves me with 8y on 3. I can't simplify 8 and 3, so that would be it. The next one, 40% people got this right. Thomas earns X dollars each fortnight. He spends 2/5 of his income on food and 1/3 on rent. Write a simplified algebraic fraction for the total amount of money he spent on food and rent. So he earns X money each fortnight. So how do we do that? Let's see how we go. So if he earns X money each fortnight, so he earns X, and he spends 2/5 of that on food. He spends 2/5 of that on food. So he really spends 2/5 of the amount he earns of that on food. So that on food would give you 2/5 of whatever you've earned. So if it was like $50, it'd be 50 times 2/5, which would be 20 bucks. You know, so we're going to times it there. Okay, so that's how much he spends on food, right? This is for food. Then how much he spends on rent is 1/3 of his income. So that's his income, and he spends 1/3 of it on that. So that is going to be X on 3. Then when it says write a simplified, so we've got to simplify it, algebraic fraction for the total amount of money he spends on food and rent. Well, this is the total amount of money he spends on food. That's the total amount of money he spends on rent. So now I need to add these two together. So there's a few steps on this one, which gets quite tricky. Now I've just got to get the lowest common denominator, which would be 15. So times this side all by 3, this side all by 5. That's going to give me 6x on 15 plus 5x on 15. That is a 15. 6x plus 5x will give me 11x on 15. And that will get you the answer there. Any questions on that one? That one was a tricky one. Application question, which gets quite tricky. The width of this rectangle. No, Jay. The width of this rectangle is 1/3. Oh, you can, Jay, start on the other subchapter, but I'll prefer to stick with this. The width of this rectangle is 1/3 of its length. That's 1/3 of its length, because if its length's y, this would be 1/3 of it. What is the perimeter of this rectangle? Well, the perimeter would be adding up all the sides, all right? So let's look at that. So really, how we can go about doing this would be, and this is where we use algebra. This is probably more getting into like what you guys will do probably in year 9, but it's more the application of it. So we know that's 1/3, right? So the perimeter would be adding them all up. So really, if you think about it, you could say, well, it's 2y plus 2 lots of 1/3, which would be 2/3 y. Alternatively, you could write it as y plus y, because it's y plus y, plus y on 3, plus y on 3. Now, you can't really add these together because these need to be the same thing. Now, don't forget, these are y's on 1. So I need to multiply those by 3. So that would give me 3y on 3, because that would be the same thing, plus 3y on 3, plus y on 3, plus y on 3. Now they're all the same denominator. I can add them. 3, 6, 7, 8. That's going to be 8y on 3. Alternatively, you could use the distribution law, which we haven't looked at. But really, you've got 2 lots of the length, right? And 2 lots of the width. So you've got 2 lengths of the length plus width, which is what you could do. So you could set up like that, and you know, well, 2 lengths of my length is y, plus my width is 1 3. Now you can just make this an equivalent fraction if you wanted, which would be 2 lots of 3y on 3. I've just multiplied this by 3 in the denominator because it's y on 1, don't forget. You got to times that by 3 and times that by 3, plus y on 3. Now I can add them together because it's really 1 and a third, which is like 4/3. So it's 2 lots of 4y on 3. Now I can just multiply this because I've got 2 of those because it's 2 times that, which is going to give me 8y on 3. So a couple of ways you could do that. Either way would get you correct if you just want to add them all up, or you could use distributive law. Hopefully that one's all right. Yell out if you got a question on it. The 10%er, this is the one I was interested in. The average of 2 fractions is this. The average of 2 fractions is that. If one of the fractions is u on y, what is the other fraction? So it's the average. So don't forget, when we take the average, we add 2 things together, right? And then we divide by 2, and that gives me my average. So we know, right, the average of 2 fractions is 3u on 10. And we know that one of the fractions was u on 5. It's a u on 5. And we've added that with another fraction. And then we've taken that and divided it by 2. And that has to equal this. This is where a bit of algebra helps to come in. I mean, you could multiply both sides by 2, which would help you. If you did that, then you would have u on 5. Now, this one is pretty advanced, so if you don't get this one, that is okay. And that's going to equal 6u on 10. So what I've done there is just multiplied 2 by both sides, which would then turn the 2 up here. That's 6u, it looks like 6,4. Then what we're going to do is, now we're here, I've got to get this denominator to 10, right? So I know that's going to be 2u on 10. I'm just taking a few shortcuts here. Plus another fraction has to equal 6u on 10. Now, clearly here you can see that, well, that's going to be, 4u on 10. But we're going to minus 2u on 10 on both sides, which would then leave us with this equals 6u on 10 minus 2u on 10. That equals 4u on 10. Now, if you're getting freaked out by this, do not worry. So we know that our unknown value was 4u on 10, and that would be the other one. And that's where it would be for that one. So, whoop, did I get that wrong? What do I do? One of the fractions is u on 5. The other... Oh, I've got to simplify it. Whoops, it's 2u on 5. Silly me. Of course, I can simplify that. Damn it, simplification. I said that on all the other ones. 2u on 5. There we go. That's going to equal 2u on 5. That is not a negative, which is correct. Okay, so that one was quite challenging. Do not stress about that one too much. I'm not going to worry about that one. We could look at this one. I mean, what you got to do here is saying, does this equal the same thing as that? That's what equivalent means. So you'd change this into an equivalent fraction and you figure it out, and change that into equivalent fraction and figure it out. That's what we're trying to ask for there. Is it the same value? So you'd need to change that and that. To write this as a single fraction, the lowest common denominator would be what? Well, 3, 6, 9, 3, 6, 9. Like 3 lands on 6, 3 lands on 9, but 6 doesn't land on 9. So what do they all land on would be 18, because 9 lands on 18. I don't know how long I'm muted for. How long was I muted for? Hopefully not too long. I'm back. come back. So what we've got to do, when we're doing we've got to find, when we're solving this one, this is something you would want to do, be able to get. When we're adding these or subtracting together, we need to get the lowest common multiple between all of them. That probably makes it the easiest. You don't always need to. You could just do one, simplify, and then you can do the other. I'll show you 2 ways to do this. The first thing I've noticed is that the lowest common multiple of this would be 12, because that lands on 6, 12, 4, 8, 12, 2, 4, 6, 8, 10, 12. So I've got to times this one by 6. I've got to times this one by 2, this fraction. And I've got to times this one by 3 to get the denominator to 12. 6 times t would give me, or t times 6 would give me 6t. 2 times 6 would give me 12, which is good. That's what I want. Plus that 2t, 2 times t, on 12. Thanks, Ryan. And 3 times t, 3t. 4 times 2, 3 is 12. Now I can do this. So what you could do here is you could actually, now they're all the same common denominator, I can just write like that. Because you can join them all. And then you can add it. 6t plus 2t is 8t minus 9 is 5t. 5t on 12, and can you simplify that? No, you can't. That would be my
You're muted.
all the time. Thank you. Again. Yay. All right. Thank you. I do not know why it's going muted. Hopefully someone won't mute me again. Okay. So what we're looking at doing with this one is we're just going to have a quick look at these ones. So with multiplying and dividing, I find it a lot easier than addition and subtraction. And the reason for that is because if it's multiplication, you just multiply the numerators together and the denominators. If it's division, you've just got to flip it. So let's have a quick look at this one for multiplication. 3 on 10x. So we got 3. 3 on 10x multiplied by 5x on 12. So here, the first thing I would do is try and always, it's a multiplication. So you can multiply straight away, but it's actually easy to cross cancel. So we'll do it the long way first and show you why it's harder. 3 times 5 is 15x. 10 times 12 is 120x. Now what I've got to do is I can cancel out my x's, right? Because x divided by x is x. And then I can also go, well, 5 goes into 15 and 5 goes into 120. 5 into 15 is going to be 3. 5 into 120 is going to be 24, right? So it gets quite tricky to do these numbers. 3, 6, 9, 12. 3 goes into that. Okay, so that leaves me with 3 on 24. And then I can simplify again. 3 goes into 24, which is 1 on 8. Now, that is the harder way to do it because you're making really big numbers. The easiest way to do this, I wouldn't do it that way. I would cross cancel. So once you've got your multiplication, and you can cross cancel the numerator with any denominator as long as they're multiplied. So I can cancel x with this x. 10 goes into 5. 5 would leave me with 1. 10 into 5 would give me 2. 3 and 12 go together. 3 will go into 3 once. 3 will go into 12 4 times. That leaves me with 1 times. This is 1 because we cancel out the 5 and the x on 4. This will leave me the 1 on top. We've cancelled out the 10 and the x. We cancel out the 10 for 2, and that will be on 2. Now I can just multiply the numerators together, which is 1, and the denominators together, which would be 8. That is a lot easier to do. So I would always cancel down first before I do multiplication, because I really don't like simplifying big things and I prefer to make it easier. So something like this, we'll do the same thing, except we're going to flip it first, and then we're going to do the same cancelling down. So it's 8x on 21. And we're going to divide it by 2y on 7. So we kind of explained why we flip and do that earlier. So I'm not going to go through that today. I'm just going to go through just purely the math of how we go about solving it. 21, I'm going to change this into multiplication. I've got to flip this 7 on 2y. Now we're up to the same stage as where we could cancel before, which is a lot easier. So the 2 will cancel out with the 8, leaving me 2 goes into 2 once, 2 goes into 8 4 times. I can cancel 7 and 21. 7 goes with 7. 7 goes into 7 once, 7 goes into 21 3 times. Now I'm left with, was it x? It was x and y, sorry, I just want to check. Now I'm left with 4x on 3 times by 1 on 1y, which is just y. 4x times 1 is 4x. 3 times y is 3y. Notice I can't cancel out x and y because they're not the same thing. And that's how we get that one there. So cancelling is always a lot easier than the other one. So looking at this one, a square room with side lengths of 4 meters is extended by adding a rectangular section with dimensions 3x by y, as shown. Write the new area as a fraction of the original area. Oof. So the new area, okay? So we're talking about the total new area. This is where it gets a bit, adding a rectangular section. Yeah, okay. Simplify your answer. So with there, and let's see how we go, because I wasn't too sure with this question if they meant the total area or not. It's a bit ambiguous. So the previous total area, well, to find out area is, if it was a square, is length times length. Oops. Or length squared in this case. So it's actually going to be 4x times 4x. When you multiply those two together, it gives you 16x squared. This one's getting pretty tricky. This area, what area would we add on? Well, it's 3x by y. That's the area we've added on here. So the area of the new section, I'm going to call that the original area. Area of the new section is going to be 3x by y, which is just 3xy. So the total area of these is what? My total area of these is what? Well, my total area is area equals, so let's call it the total, 16x on squared plus 3xy. Now it says write the new area as a fraction of the original area. So, well, the new area is this, my area total, as a fraction of my original area. Well, my original area, let's call that original, and let's call this built on or added. So we'll call that A, over my original area. That's how I've interpreted it. So my total area now is 16x squared plus 3xy and over 16x squared, right? Now this is tricky. I can't cancel out that one with that one because it doesn't really work. I could separate these though, but I think they just want it as a fraction, right? Simplify your answer as much as you can. Write the new area as a fraction of the other one. So if I could simplify this, I mean, I can take out x from here. I can't really take out 16, so I think I've done this one wrong. So I could take out x as a factor, 16x plus 3y. That's going to be on 16x squared. That x would cancel out with that one, which would just leave me with 16x on x, which is really 1 on 3x on y. But we'll see how we go with that. I don't know if that will work. 16x plus, no, it's not going to let me do it. So I've done something wrong there. Let's see what the answer is. I didn't get it, and that always helps us. The correct answer, 3y and 16x. So it's 3y on 16x. Okay, so what they're saying is, and I did interpret that wrong, write the new area, so just this area as a fraction of the original. So that would be, I'd imagine the new area then would be 3xy as a fraction on the original area. which would be the original area was 16x squared plus 3. Sorry, it's just 16x squared. Let me do that again. So the original area, the new area is 3xy on 16x squared. I can cancel out the 16x squared. I can cancel out the x with the x, and that would leave me with 3y on 16x, which probably makes it a bit easier. 3y on 16x. So I misinterpreted this because I misinterpreted this as this is the new area, right? The new area as a fraction of the original area. I mean, I kind of suppose that is the original area. That is the new area. I'm kind of thinking this as the whole area, like the new area, and that's where I went wrong originally. That's okay. And that one's quite tricky, but let's move on. A fraction AB is multiplied by its reciprocal. A reciprocal is basically B over A. So a reciprocal always gives you an answer of 1. So for example, if I say, hey, what's the reciprocal of 4? The reciprocal of that is a quarter. Why? Because 4 is really 4 on 1. If you times these two together, it will always equal 1. So the reciprocal of A on B is B on A. And if you times these two together, it's going to leave you an answer of 1, because that's 1, that's 1, that's 1, that's 1, right? So the result is 1. So reciprocal is just, you got to flip it over. So why we call it reciprocal is because that helps us when we come into this, the expression of 2 on x divided by 3 on 2. What you do is you make this a reciprocal and you change it into multiplication. So you do the reciprocal of 3 on x, which will be x on 3, and that's what we're actually doing. Simplify that. Well, that's really a on 1. So the a's will cancel out, and the answer for that would just be 1, which is very similar to what we just did. For this one, 2/3 on x, 3 on x. Okay, so really what we got here is we've got 2 on x, on x divided by 3 on x, and I'm about finished here. What we got to do here is I've got to do the reciprocal of that, which is 2 on x, and change this to a multiply, x on 3. Cancel these out. That will leave us with 1. 2 times 1 is 2. 1 times 3 is 2/3. And that would be your answer. The expression of this will always have the same value regardless of the value of x. Well, it will, because the x's cancel each other out. It doesn't matter if this is a 6 and that's a 6, they're going to cancel each other out. It doesn't matter if this is a 5 and a 5, they're going to cancel it out. Because at the end of the day, what I will get you guys to do is I'm going to leave it there. Please try your best on that one, and I'll get you to work on the rest of the subchapter, the maths space homework